Good day, everyone. Welcome to exercise 2A, Irrational Numbers and Surds, Part 2. Now, in these couple of exercise questions on exercise 2A, question 7 all the way to question 12, as we carry them out, it's just basically a recap of what we have learned previously in terms of the basic rules around your square root. So it revolves around these four formulas that we have talked about before. I'll begin with a recap, and then after that, we'll do a couple of questions from question 7 all the way to 12 as we build up our knowledge in being able to apply these basic rules to some real-life examples with our analysis sort of questions. Right, so firstly, as we recall, now all these formulas, they look a bit daunting, right? But just basically with the first two formulas over here, you can see that they are just reverse processes of your square root. So let's say, for example, if we have square root of 4, and this is not a surd because you can square root 4 and that gives you 2, a whole number, so therefore this is not a surd. But for the purposes of an example, I'll just show you why this relates. So if you have a square root of 4 and you square that on the outside, right? What this means is when you square root 4, you do get 2, right, as a whole number on the inside, and you will have square on the outside. Right, so simplifying that 2 to the power of 2 just means that 2 times 2 will give me 4. Right, so you can see the original number of 4 that's inside the square root in itself. It repeats as well on the outside, just that there's no more square roots. So by squaring your square roots, this is just basically reversing the process of that square root. Right, we can also take this example here to our first formula that you have. So if you square root, let's say, an abstract a, and then after that, followed by squaring that, you will get an a. Right, with the second one over here, quite similar, we can also use a perfect square once more just to illustrate that. So we have square root of a square. In this case, we'll put that to be 4 squared. Right, so if we were to apply BIDMAS, we will have to solve whatever that's inside the square roots first. So what this means is 4 squared, this will give me 16. So a square root of 16 on that next step. Right, so you can see if you're square rooting that perfect square there, that will give you a solid 4 as a whole number. Right, so once again as well, with this process, it's the same as well. If you were to square the number that's on the inside of your square root, right, this will undo the process and give you a whole number in that sense, right? So if you have a square, and then after that followed by a square root, it's just undoing the process. And in fact, these two examples are just your inverse process, right? We'll need this all the way through to the next exercise as well, as you remember that. So squaring your square roots will inverse the process. So this ties back into your second formula over here to make that true. And always remember, this is only if A and B are positive numbers. So at this moment, we're just dealing with positive numbers. Now with your third formula here, so let's say, for example, if I were to take a square root of 4 right over here times a square root of 9. Right, if I were to work things out without using this formula here, I will get 2 times 3 equals to 6, right? But if I were to use that formula here as well, and you can see that it also works out to be the same answer. So if it's square root of 4 times square root of 9, I can combine my 4 times 9 within the square root itself, right? Multiply that, I get a perfect square number as well. Again, 36, right? So square root of 36 in terms of the answer. Simplifying that, I still get 6 as well. Okay, so therefore, when you have a square root times another square root as well, making sure that your roots are the same, right? You can combine them and also multiply the numbers that are inside the square root. Lastly, we have your square root of a divided by square root of b here. So once more as well, I can use the same analogy of square root of 4 divided by square root of 9, okay? And you can, if you do it the hard way, square root of 4 divided by square root of 9, you get 2 divided by 3, and that will be your answer. Right, if you were to apply that sort of knowledge as well, the same thing would happen. So if you were to have square root of 4 divided by square root of 9, you can combine them together. You will get 4 over 9. And then after that, simplifying that, so you get square root of Yeah, square root of 4 divided by square root of 9. So square root of 4 will give you 2. Square root of 9 will give you 3. Okay, so it's the same ones that you get. So you can combine your a divided by b as a fraction within that square root there. Okay, so just these 4 basic rules in itself, and we'll now apply that to the other questions below. Right, also do note before we begin exercise 2A, questions 7 to 12, that just for the purposes of the illustrations above here on how all these formulas have been formulated, these are not surds, right? Because you do square root them and they give you a perfect whole number, so these are not surds. But in knowing that this works, when you pop in a surd in itself, it will still work as well with your 4 basic rules. Okay, exercise 2A, question 7. So 7A, it says simplify square root of 2 times square root of 7. So I'll copy that out, square root of 2 times square root of 7, right? So with our first rule, you do know that you can put 2 times 7 within your square root in itself as you simplify that. Simplifying what's on the inside of your square root, and that's square root of 14. All right, so that'll be your answer for that. Now, for question 7e, so same thing, 7e, square root of 12 divided by square root of 2. Once more, we can use the basic rule of square root of a divided by square root of b, and we'll just combine those division numbers within as a fraction, right? So we can express that as 12 divided by 2 and square rooting that whole thing. All right, simplifying that, 12 divided by 2 will give you 6. So therefore, square root of 6. Right, question 7F, right? So these are just a couple of selected questions that I'm doing. You will have to complete the rest of the other questions on your own in your own time. But these couple of examples will give you a good enough guidance for that. So we have square root of 5, squaring that minus square root of 5 squared. Okay, so same thing like what we have done above. We know that if you were to square a number and then square it, it will inverse the process. So this will give you 5 as your answer. So this relates to your very first rule over there. So therefore, that will be 5 that it amounts to. And then after that, minus 5 square and square rooting that. So we know that 5 square will give us 25. I'll write that just at the side, 25. So this means square root of 25, and that will give us the same whole number that you see over there. So 5 minus 5. And this relates to your second rule that you see up here, right? So making use and applying all these basic rules there. So 5 minus 5 giving us 0, and that will be your answer. Now, question 8, we'll have to complete the mathematical equation here, and that is backtracking in that sense. So like what we've worked on over here, let's have a look at 8a. Right, we have square root of 5 times whatever that surd is that you're supposed to find out equals square root of 30. Okay, we do know that in terms of square root of 30, we can factorize them. So you're thinking about what are the sort of numbers that will give you 30. So you have 1 times 30, you have 2 times 15, you have 3 times 10, 5 times 6. Right, but do we all need to carry out all this whole method? Answer is no. So you do know that 5 times something within the square itself, it will amount to 30. So straight away, you can locate that. If you would like to get 30 and you like to factorize out 30, this can be split in terms of 5 times 6. Now, working backwards, we do know that we can detach this. So therefore, that will be square root of 5 times square root of 6. So in actual fact, for our answer, this will be square root of 6. Okay, let's do another example here, and this involves division once more. So working back on the general rules that we have identified above. So with 8d, we have square root of 100. Our task is to find out what is that denominator there that will give us square root of 20. Okay, so we'll be thinking about if we were to break this up over here, 100 divided by something equals to square root, and square root that equals to square root of 20. So you'll be thinking about what is that factor that will give you 20 times whatever that will give you 100. So working backwards, you'll do 100 divided by 20, and that will be 5, right? So this means that if your answer over here, that will be a square root of 5. Okay, you can also still check back again. So I'll just put this in green first before we begin checking. How can you go about checking if it is square root of 100 divided by square root of 5, right? So we combine them together on 100 divided by 5, square rooting that. 100 divided by 5 will give us 20, and square root of 20 is our answer, as what they have written over here, right? So therefore, that will be our answer for 8D. Now, question 9, this is where we apply our knowledge on the 4 basic rules of our square roots in some real-life examples. And we do get to use a bit of maybe Pythagoras as well in the next couple of questions. So I'll do question 9A. Find the area of the rectangle with height square root 7 cm and width square root 3 cm. So 9A, let's first draw a diagram just so that that's easier for us to understand. So I'll always encourage you to draw that out just so that you can visualize it better. So area, we know that area is, our formula is area is length times width, right? So they have stated that our height, that is square root of 7, and our width is square root of 3. Okay, so in being able to find out the area over there, so length will be square root of 7 times square root of 3. Right, applying your knowledge, you can combine 7 times 3, square rooting the whole thing, and your answer will be square root of 21. Right, and your units will be squared centimeters. So don't forget, this is area, so therefore you do need squares. Now let's carry out for question 9D. Right, this is a reverse process. So right now they've given you the area. So a square has an area of 11 squared centimeters. So this is our square. We all know that a square has the same sides, same length on the sides, and an area of 11 squared centimeters. Right, so what is the length of each side? So in knowing that what is the length of each side, we know that, let's say, for example, we let the sides of the square be x in that sense because we don't know what's that, and we can find out what that is. Area equals to length times width. So in that sense, 11 is our area, putting our numbers into the formula, equals to x times x. And when we simplify that, that's 11 equals to x squared. Now, finding out what your x is, and I'll switch that over, x squared equals to 11. Finding that out, when you remove your squares, you're just basically square rooting both sides of the equation. So square rooting the left side, we'll get x, and on the right side, we'll get square root of 11 there, right? So this will be our answer in terms of the length of each side being a square root of 11. If you'd like to check back as well, you can pop this into the formula. When you do square root of 11 times square root of 11, you will get 11 in that sense, right? Now, question 10. Use Pythagoras theorem to find the value of x in exact form. Now, if we recall our knowledge on Pythagoras theorem, we will need a right angle triangle, okay? And these are perpendicular to each other, so these shorter sides here. So we know that the sum of the square of each sides, so sum of these squares of each sides, equates to the square of the longer side, the longer diagonal, which is called our hypotenuse, right? So therefore, see square over there. Pardon me, I shouldn't put squares on the figure, right? Only the formula has that. Okay, so therefore working with this formula, and how do we actually apply our knowledge and also find out what is the length of each of the sides that they have labeled x. So question 10a, if we give it a go, use Pythagoras theorem to find the value of x in exact form, right? So our a will be 3 and b will be 3 as well. So popping them in for 10a, right, 3 square plus 3 square equals 2, and c in this case is x, right? So x squared. I'll just switch that around just so that it's easier for us to recognize that our unknowns are on the left. So x squared equals to 3 squared plus 3 squared. Okay, and then after that, simplifying that. So you can simplify that as 9 plus 9. Okay, resulting in 18. So x squared equals to 18. So remember, if you like to remove that square over there, basically you're just square rooting that. So square rooting the left side on x squared, that will just give you x. And then on the right side, doing the same thing, square root of 18. So therefore, that's your answer with 10a. If they've given you units, have they given units? No, no units, so you don't have to state that there. Right, so give it a go with the next couple of questions over there as you arrange them and also find out your unknowns there. Right, question 11 and 12. I'll just do question 11 because these two are quite similar in terms of what we need to find, so it's different shapes. Okay, for question 11, we have a square has a side length of 4 times square root of 7. So we have a square. Let's draw out a square. Right, all sides are the same for squares. And we know that the side length is 4 times square root of 7 centimeters. Find the area of the square. So 11a. Nice and simple. We know the area is length times width. But for the sake of squares, you do know that that can be just whatever the length is, and then you square that. Okay, I can write it out in full. So 4 times square root of 7 times 4 times square root of 7. Now, as you multiply your surds over here, you can expand. So if you expand them, that will be easier. This means, so 4 times square root of 7 just means 4 times square root of 7. Okay, so just showing you that. And then multiplication sign in the middle, same as the one that's on top. 4 times square root of 7. Okay, so this is your expanded form. Now, the next step is to reorganize. So all your numbers, your whole numbers, put them on the left side, or start off in reorganizing them first with your whole numbers. So we have 4 times 4. Okay, and that's it for my whole numbers. And then after that, lining up your square root of 7 times your square root of 7. Okay, so you'll simplify that on the next stage. 4 times 4 will give you 16. And then after that, square root of 7 times square root of 7, right? This will undo it basically, right? So this just basically means it's your square root of 7 squared. That's the same rule that we have learned before. So therefore, you know that this is a times 7, right? So if you pop that in on your calculator, that should give you 112 squared centimeters as your answer. Right, 11b, find the length of the diagonal. So what we mean by diagonal, that is this orange line that I've just drawn here. Okay, so we do know that the sides are 4 times square root of 7 and 4 times square root of 7 on the bottom as well. Because there's a square, it is perpendicular in terms of the shorter side. So this is where we'll make use of our knowledge on our Pythagoras theorem, right? So Pythagoras theorem will tell you that the square of the longer side, which is your hypotenuse, is equal to the sum of the square of your shorter side. So that is a square plus b square, right? So c square equals a square plus b square, or a square plus b square equals to c square. So in that sense, identifying our a and b, right, that will be our 4 times square root of 7 for both. And then after that, your c will be that area, that length that you have to find. Right, so with that, you can identify that a equals to 4 times square root of 7 and b equals to 4 times square root of 7. Right, so finding out what c is and placing these values and substituting them in there. So we have c square equals to square of 4 times square root of 7. Right, and also adding the same thing as well for b squared. Okay, now in applying our squares to this entire thing, because 4 times square root of 7 is as a number and is in the bracket, so we take that to be a whole number in itself, right? So where it's all tied up in a nice and neat package. So this means that our square is being applied to 4, and our square is also applied to the square root of 7, right? So if we were to do the next line in simplifying that, so the square root of 4 will give us 16, right? And the square root of 7, squaring that, right, will just undo it. So just for example, like what we have done earlier, so square root of 7, you square that, okay, and that will undo that. That's just basically 7, right? So this means 16 times 7. Okay, so I've simplified this over here. let us simplify the other side as well. So I'll put my plus sign, same thing. And also with the same thing, your squares are being applied to your 4 and also the square root of 7. Okay, so if you can do 4 squared, that gives you 16 times squaring your square root of 7, giving you 7. All right, then after that, simplifying that, you have 16 times 7, giving you 112, plus same thing, 16 times 7, 112. Right, and remember, this is still c squared, so therefore when you add both up, c squared equals to 224. All right, and on the last stage, because you only need to find out what c is, therefore c equals 2, and you're trying to undo that square there, so therefore you square root both sides of the equation. Right, so square rooting both sides of the equation, on the left side you just get c, and then on the right side is square root of 224. Now, this is not all that it is with our final answer here, right? We still have a couple of perfect squares that are still in here, right? So putting together our knowledge, how can we factorize and split up 224 as we multiply one factor with the other factor, right? So if you were to carry out your times table and also note your perfect squares, try out different perfect squares as well, and you'll note that your perfect square of 16, right? 16 times 14 on the calculator will also give you 224. So you can split that. All right, and then after that, simplifying that, square root of 16 times square root of 14, that should give you 4 times square root of 14 as your answer. Right, so always remember, as you simplify your square roots, you need to ensure that there is no more perfect square factors within, and it can possibly only have one, I would say one and that same number as your simplified form on the inside. Right, so give it a go with the next questions that we haven't completed, with question 7 all the way to question 12, please. Thank you.